Welcome back to the series on accident reflections. This time we're going to have a look at Baron 58, and on here you can see we're going to talk about Vmca. Now a little bit more about what Vmca is for those that don't know the terminology, but the multi-engine aircraft guys, I'm sure that you will know. Also note here this is article number or presentation number 7, and that there are articles available on all of these as well. All right, so if you've been here before, welcome back. If you haven't been here before watching the series, well, welcome. And you can continue watch all the stuff. Let's get stuck into this. First of all, we're going to look at a Baron 58 at Phalaborwa. There's an aircraft there in the northern, more northeastern side of the country. But that is probably not of that much importance. But however, no arrangement to land at Phalaborwa airfield to drop off the passengers was made. That's one of those little airfields where there's not always people, and to be able to get service on the other side, you've got to let them know, because it's not a regular busy aircraft. Is that important? Towards the accident, no. Towards the way how we plan and if we do proper, complete, entire plan, yes. But no, I don't think it's part of this problem here. Now, after takeoff, the aircraft take off on runway 19, positioned on right-hand downwind, indicating intention to return to the airfield. Now, so there's the airfield, here the airfield. So he's taking off and he's turning downwind with the indications that he wants to come back. All right, now, this was now heard from the ground. Strain noises from the aircraft engine on downwind, and then the right engine shut down and feathered. Right, so up to now, what we know is airborne, getting some trouble with the right-hand engine, turning out right, now want to go and land back on the airfield. Okay, so engine now shut down and feathered, and actually that is spot on. Downwind was closing in on the runway extension, and here you can actually see that, and if you take the extension of the runway and you run it like that, then this space here, the pilot was very, very busy. And at the end of the day, when he wanted to turn here at the bottom, it was a very tight right-hand turn, and the aircraft then entered into a spiral. All right, so because it is the fact that it's only got one engine now, that is where the minimum control speed air comes in for single engine operations. And that has got everything to do with this engine. Now remember, this is the right engine and the right-hand engine, and the turn onto final was to the right, and it was very steep, and all the makings for bad news. All right, but now, well, nothing personal here. We must just learn from this. Learn so that we can tell and teach the next as well. Accident sequence, just to quickly run through that to make sure. Takeoff from 1919 right, engine cut, feathered, drifting towards the final path. That's very important. Steadily losing height. Yeah, okay. It makes you immediately think, but Baron 58, is it possible that it cannot maintain at least blue line plus 10 on one engine? I think it could. But you see, once you get distracted and you haven't properly trimmed and stuff like that, stuff like this happens. Not once, all the time. Believe me, I fly with a lot of people, and that's pretty normal. Okay, then a tight nose, relatively high turn onto final, because he's now low, and you can see that on the extension of the runway where the accident was, he got down and he drifted towards and he tried to turn inside. Now the aircraft entered into a spiral, a loss of control, and we'll talk about the spiral condition there. Is it a spiral condition? Is it a stall condition? Whatever it is. High speed and steep inverted. Shame. That was an inverted, the aircraft actually flicked inverted, and it was a fatal accident. Now, let's just look a little bit what we're going to add into the argument. Now, remember, I'm not arguing with the pilot. I'm not arguing with anybody. The argument simply means that when we start analyzing the stuff, what is it that we should bring in? Now, there are a ton more things that I could bring in here, okay? So these are just a few selected ones. But here, very important, bank into the dead engine seriously increases the red line speed. Now, all pilots all out there will know that the red line speed is the minimum speed for control once you have lost one engine. I know there's other parameters as well. But we've got to understand that we've got to have the utmost respect for the red line. And if anything in our minds, the red line must go up. It can never come down. Okay. I know there's other cases that it could probably slightly slower because it's not this and this and this and that. You are really playing on the edge. Okay, so stick with this one. Now remember that when you get an engine cut, you always have to put 5 degrees bank into the live engine. Immediately, you will, physically if you're going to, you'll see that your airspeed will increase by probably 5 knots. But now as you bank out or away or into the dead engine, that is where the red line starts creeping up. Aerodynamically, it's a whole lecture on its own, but let's look at the facts that we have so far. Pilot aware of the engine problem, and he did a successful feathering and shutdown. Great stuff. Good positioning to land on runway 19. That could have been. But now the pilot is so distracted that he is actually tightening himself, and he's putting himself in a very tight spot to turn final. Will that happen? It happens, okay? But that doesn't mean that now because you are tight, that's one mistake. You cannot correct that with another mistake by putting in too many degrees of bank. You can't. You've got to still do it easy, and then you're going to do a wide hammerhead, but you cannot do the tight turned thing into the dead engine. You cannot. It's not me saying so. It's aerodynamically proven. It is mechanically proven. It is experienced proven, and all that kind of stuff. Okay, the aircraft, I know, is close to the ground. It's you know, it is, if it was high, I don't know, if it was a glide approach, the other engine probably was working hard. Decided very late to turn final, although the one engine should have been good. What I meant here with high is that if you're high, you could actually cut the other, well, retard the other engine and just fly in and do a glide approach. But anyway, all right. Having been good, consider dead engine for speed requirements. Lost speed, bank into dead engine increases Vmca significantly. The minimum speed of control that you have over the aircraft will increase, in other words, become worse. If 5 degrees bank, let me do that, 5 degrees bank into the live engine, no degrees, in other words, it's 5 degrees less already, and now you start turning into the dead engine. And all that red line is doing, and I've got the formulas and I've done the presentations on that. But believe me, for your red line to rush up and go and meet the blue line that high is very, very possible. and you don't need that much bank. And in this case, the bank angle, I believe, would have been well in excess of 30 degrees. Never mind. Let's carry on. Okay. Starting the turn, the G-forces increase. So what does the G-forces got to do with it? Whoa. Whoa, 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 whoa. Remember, under any condition that you are flying, the maneuver stalling speed is directly influenced by the amount of G's. Yeah, but Charlie, come on, man. I mean, this guy, you know. All right, so he's pulling 1.1, 1.2 G's, maybe 1.3 G. Now, I can put that in your calculator and look at the basic stalling speed, or the stalling speed. Remember now, the Vmca is the speed where the aircraft becomes uncontrollable. In other words, there are not enough rudder anymore. Now you're going to put load on the aircraft as well. Now you're running into a double whammy at this stage. Okay, loss of control could have been sudden and not recoverable. Whoa, I've got to comment on this. Yes, loss of control is sudden. Loss of control in this case went sudden and into inverted position, and the aircraft was now probably spiraling down, but it's so low above the ground that there is not enough sky left to recover. Have I been upside down in an aircraft like this before? Yes. When we do certain test flights, we actually do go inverted. It's not a problem. If you've got 3,000-4,000 feet below you, then it's not a problem. You know what to do, it's not a problem. But even with all the experience that I have in this stuff, I will never be able to avoid this. If you get into it there and there's no more sky left, then, well, Mother Earth will smite thee. All right, let's look at the... I'm so sorry, I've got to say again, yes, same trap, different victim. And we must really live and learn. But you know what? I get despondent about that, because we must teach this. We must get the people to know there are no-nos. And at certain heights, if you enter an area that you shouldn't be, there is no recovery. All right? There is no plan B. Okay. The initial failures of the handling emergency, good? I think so, very good. It was not preserved, lead to excessive speed during the downwind. All right, say you're flying away from the runway. Okay, speed was never a problem in terms of the Vmca initially. And then the height ran out. How, you know, when you've got to preserve the height and do a steep turn, you're bleeding the speed and. All right, now let's see, turning on to final was commenced at around 550 feet above the ground. Now, that is about 500 foot too low. I think one must just go back to what you want to be 500 feet, final approach, fully configured. That's not, well, that's the guidelines. And those are serious guidelines. Okay? That's what the guys say. 500 feet, established in the slot, or finished with a configuration. But now you're sitting at 550 foot. You are too low. You cannot now descend because you're already too far out. You're 500 feet too low. You've got to get the nose up and you've got to turn. That bleeds the speed and. It's really now becoming the one error leads to the next error leads to the next error. All right? So a chain of events? No, I wouldn't call it a chain of events. I would just call it now events that are happening, because when you make a mistake and you correct a mistake with a mistake, or you force yourself into a mistake, not sure if you can call that a chain of events. But anyway, it happened sequentially, I suppose you could. Turning into a dead engine increased the red line speed to the blue line. Tighter turn increased the stall speed and handle speed. Handling speed, the aircraft was lost at 460 feet above the ground. So from 550 to 460, you know, there's only 90 feet that he descended in the tightness of that turn. And they say lost the aircraft at about 111 knots. Okay, remember that would have been a ground speed measurement, maybe where there was a little bit of a wind. So the speed could have been, or let's say the airspeed would have been slightly less than that. So with the bank angle above 30 degrees bank, that's where the trouble comes in. So now we put everything together. Because we're turning into, the red line has moved up, we're trying to tighten the turn. Man, remember that the ground speed indicated airspeed because you're turning into wind. So I think the indicated airspeed could have been a knot or two, maybe 5 knots less. Never mind. The fact is that we flew into a corner out of which there are no way to recover. Okay, recommendations. Again, as in the previous, all air vehicle types. Not really. All multi-engine air vehicle types. All right? So all of you, you've got that problem. One must do the initial procedures as he did, but must preserve the potential energy or even gain height if it's allowed. All right. The first thing that we do when we get an emergency is to stabilize the flight environment. Aviate. Then navigate is the planning. And then we tell people what we're going to do. That's to communicate. All right. So aviate. But what does aviate mean? Means you've got to stabilize your speed. You've got to trim the aircraft. You've got to see. If you've got excess energy, get height, my man. Because if you pull the other engine off, you can probably glide to the place. But to throw away height is you just throwing your chances out of the window like that. You are really doing that. So the stability of the flight is the first thing. Then you can't drift. You can't. You and the runway and your aircraft must become one. Okay. Speed control must be around blue plus 10. Anything higher means energy dump. Okay. In other words, what I'm saying is that why push up the speed? Because somewhere the energy is coming from. And in this case, it was coming from potential energy, which is your height. Keep the landing site in mind and sight. To be higher than needed, that's good. Because you can always put more drag and full flaps and undercarriage and kill the other engine and do a lot of stuff. Undercarriage only if absolutely reach the field or the flap is required, preferably full flap, because that is how you want to go with the slowest normal speed. And then turning into the dead wind and always need more speed. At least blue plus 15 up to 20 knots when exceeding 50 degrees, 15 degrees. Whoa, what am I saying? This is the point. Because a lot of people ask me, but I've got to turn right now. I can't turn left. Remember the first thing. If this person, and I'm terribly sorry, but if he could have just preserved his height and stabilized his flight and calmed down, then things might have been different. Can you turn into the dead engine? Well, you can. Is it advisable? Not really. But if you are forced to, and there are no other options, let's say you've got a mountain on the left, you have to turn right. That's when you must have the speed. So normally we will look at blue plus 10. That's a rule of thumb in these aircraft, okay? Now I'm not banking into the live engine. I'm now taking off bank, or I'm banking to the right. You can't maintain blue plus 10 because that red line is now moving up to blue and your margin is now coming. It is just deteriorating by the second. And that is why I'm saying, if you are really forced to, then in that turn, do not exceed 20 degrees bank, even if it means that you're going to do a hammerhead. It's no problem. Do a hammerhead and go in. Nobody is clapping hands for you. Okay? Well, not yet. But the thing is, as you turn around there and you maintain your speed at blue plus 20, you probably have got a good chance, but you cannot do hard and jerky maneuvers in anything. All right, it's a difficult one, and I hope that we have just learned that it's great that we're doing the first part of the emergency right. But it's not good enough. We've got to do the whole thing right. In a single engine, if you set yourself up for a forced landing, if you get the first part right and you screw up the second part, then it's all for nothing. All right. Please go out there, think, learn, listen, and remember, whenever there's an emergency, the first thing is to stabilize the environment. Until next time.